good morning, guys. Anybody? I've been answering a few questions. You guys have any questions from homework or general or anything? I'm going to be a little surprised if there's no questions. I had a few questions in office hours, but some of this stuff gets a little bit freakadelic. So one thing I want you guys to realize is when you start doing the homework, you're not necessarily supposed to know exactly what to do as you read through it, right? I just want to make sure you understand how this works. So when I first see a problem, I don't automatically know what to do with it. I have to think. I have to read through it. I got to think what that might mean. And then I go back. Once I figure out, I think I need to do this, then I go back and get the specifics. So that's related to somebody asking me, is it wrong that I have to read through several times? No, that's right. That's what you got to do for almost every math problem. You should read through it a couple times. The first time just to get a feel for it, and the second time to get the details. So with that said, I do agree with some other students who said the book has a rough time trying to word things sometimes. I agree with that. But like I said, that's another life lesson. People have a rough time trying to figure out how to word things. Unfortunately, very often they are our leaders. But anything from homework? Are you guys? Just going to keep getting more and more political. I'm sorry. Huh?
I thought that was pretty
So number 8 in section 2.4, I still tried to attempt to go through it. I did turn it in. I don't know if you saw it, but I'm just completely lost on number 8 there, setting it up.
All right, let's see. 2.4.
I think it's page 206.
Oh, thank you. Yes, okay. Let's take a look here. Good old glacier problem.
It's killing me.
That's what we're doing here in this class. We're solving the glacier problem. Actually, I guess climate change is solving the problem. All right. I'm just going to keep getting more political. That's all there is to it. How long would it take the glacier to move the length of a football field? Okay. All right. Okay. So at this point, either you have done this and turned it in, like the person I'm talking to right now, or you've done this and you're about to turn it in, or you haven't done this at all, which is, bleh. So let's do this. Let's just freaking do this problem. So coming back up here to number 6, so I can build my way up to number 8. How fast was it moving in inches per hour? So it's 203 millimeters per day, right? And I want to go to inches per hour. So you just pick one of those. Which one do you want to do first? Don't everybody?
Inches?
Inches, okay. So let's change to inches first. So they tell me, well, here we go. They give me this. And notice, remember that 1 inch is 2.54 centimeters? Remember that? Remember that? You guys don't remember that? All right.
Yes.
Yes. And then every centimeter is 10 millimeters, and that's why that goes over and becomes 25.4 millimeters. That's how they got, but they gave it to us. That's nice of them. So where would I put inches? Where would I put millimeters?
Inches on top, millimeters on the bottom.
Yeah, millimeters definitely in the bottom, so they kill each other. And then I can fill in the number, 25.4 and 1. I like it. So a lot of you guys are just trying to skip this step and just guessing as to whether you divide or multiply. Why? Why would you do that? Make the unit die, put the other unit want to go to on the other side, and put the numbers in. So now I'm in inches. Beautiful. Inches per day. I want inches per hour. So now I want to go from days to hours. Where would I put days? I don't know why I just drew. Let me get rid of that. I want some room. Get out of here. All right.
So put the days on the top
Yeah, sorry. So days up top, why?
because you want to cancel out the days.
Yeah, I
and
want to
just the
kill it.
hours.
Yeah. Do you guys see how nice that is? Like I said, that's I know it's kind of math, but it's barely math. It's freaking words. And you just make sure that this word goes across from where it already is so that they cancel. Now I can fill in the numbers. One day.
24. Yeah.
All right. So what am I going to put in the calculator to do this? So now I'm going to be inches per hour. Those are the ones that survive, right? So if I do this, what am I going to put in the calculator? 203.
Divided by
What am I going to put?
5.4
Divided by 25.4.
divided by 24.
Kick ass. All right. And what do you guys get when you do that?
I'm not doing it. What was that?
0.333, something a lot.
0.3330.
Yeah, that sounds right. There it is. 0.333. Okay. And it says, does it say to round something? No, we're just going to round to this because we're not crazy. We're not going to keep going. And that's going to be inches per hour. Do you guys notice how units they're always important, but they're extra important in this section because this is all about units. So if you don't put units down, you're going to lose more points than normal. So units are huge. Okay. Pretty cool. That's number 6. Now it's a gimme. This is not the lesson to take away here is you don't just go, I'm not going to do my homework because then maybe Mr. Wall is going to do it for me. Ha 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 ha. No, I ain't going to do this shit again. But I want to do this because this problem is neat. And those of you who think you don't need this, after I've graded some of your work, I hope you realize you do. Some of you guys are just go, go, go. And I'm like, no, this helps you know when to divide and when to multiply. That's what this does. So why not do it? So now I'm in inches per hour, and now they want miles per hour. So how do I go from inches to miles? We pretty much did this yesterday. I just didn't use the right stuff.
We break out inches to feet, right? From feet to miles.
Yeah, so I got 0.333 inches per hour. And now I want to go from inches to feet. So where's inches going to go?
Bottom.
Bottom, so that they kill each other. Go to feet. So now 12 inches in a foot. And then where's feet go? I'm going to go from feet to miles.
Bottom.
Bottom.
It goes on the bottom.
Okay. And then what numbers go in here? Who remembers? 1 mile is?
I think it's 5280, 5230 or 80 or something. Yeah.
5280. I love it. That is, I really, this is so beautiful because you just worry, the first thing you worry about is just make sure the units that you don't want anymore die. I don't want inches. I don't want feet. Now I got miles per hour, which is exactly what I want. And now if I just do the numbers, the units are already correct. So then I'm going to do 0.33 divided by 12 divided by 5280. And you're going to get something silly small.
I have a question.
Yes.
So the problem before, maybe this is why I'm having a hard time like kind of understanding it, is that you're putting the hours into play for the answer. And I'm like, so is there a way knowing like long math why we're allowed to do that equation like that?
Okay, I'm not sure exactly how do you mean. You said the hours. What about
Right.
the hours?
So the centimeters come or the inches come into play hours in that equation, right?
Wait. So
we're using the measurements. Okay.
So I know I'm not all right, I think you're looking, these have nothing to do with each other.
But in the but you divide it to get the inches per hour, right?
Totally. But they don't do anything to each other.
Right.
Yeah, okay.
But when you're using it in the equation, you do 203 divided by 25.4 divided by 24 to get the inch per hour.
Sure, okay.
So I'm just confused. So maybe this is why I'm confused, why this isn't adding up to me. Even though I know how to set the equation up, it's just like not clicking. So maybe I'm not wording this right. I don't know, because the 24 is divided by those two numbers to get the inch per hour. Like, why? I don't get it. I'm like confused. You don't know how to help me. You look confused yourself.
All right, so you just said the 24 is divided by?
The 25.4,
Yes.
right? It's divided by all that in the
It's
equation.
divided into.
Yeah. Into
okay.
the whole set. I'm just
Sure.
confused why to get that answer.
All right, let me think.
Is it because 25.4 is the number of inches and 24 is the number?
It's the number of millimeters. So, all right, go with me for a minute. You ready? Let's deal with something. So I know that 1 inch is 25.4 millimeters, right? I just know that, right? What we're actually using, and I appreciate your question. I think you want to know, what does this look like? Not this quick way. What's it look like in a more purely algebraic way or something?
Yes.
Okay. Blah, 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 blah. Okay. So now watch this. So therefore, now watch. Now you don't have to ever do this. Is everybody with me? If I want to kind of make this into a rule, X inches equals 25.4 X millimeters, right? So if I knew how many inches, I would multiply by 25.4 to figure out how many millimeters. Does that make sense? Because I mean, before I could have said this. If 1 inch is 25.4, what's 2 inches?
It would be that times 2.
Yeah, so this times 2. So whatever this, however many inches I've got, if I don't know what they are, let's just call them X, then it'll be 25.4 times that. Of course, right? If I had 3 inches, it would be 3 times this. Is that cool?
Yes.
Okay, okay. Now watch. Again, like I said, you never have to do this. If 1 inch is 25.4 millimeters, and again, this is all a side note, but it is a good question, and this is actually good to see. Stay with me now. You ready? You ready? I can divide both sides by 25.4. Oh, shit. Then this is 1 over 25.4 inches equals 1 millimeter. So watch this, watch this. Are you guys cool if I say this? 1 day is about 1/365th of a year. Because 1 year is 365 days. So of course 1 day is 1 over 365, so 1/365th of a year. Does that make sense? Or how about 1 inch? 1 inch is how much of a foot?
12.
How much of a foot? Say again, sorry.
Wait, 12 inches in a
112.
12 inches in a foot, so 1 inch is how much of a foot?
1/12.
1/12. Kick ass, right? So now watch. So this is if I know how many inches I'm going to multiply by 25.4 to figure out millimeters. Now we divided, didn't we? Because I didn't know how many inches. I knew how many millimeters. So if I know so if I had 2 millimeters, wouldn't it be, what would 2 millimeters be? It would be 2 divided by 25.4, right? So what would X, and that would be inches. What would X millimeters be? It would be X divided by 25.4, get in there, inches. So that's why the only 2 things you could ever do with the numbers that I'm given are multiply by it or divide by it. So we knew millimeters. I know I have a certain number of millimeters, so I'm going to divide by this to get how many inches that is. And let me, all right, so that is the very technical way to look at this. So let me see. I don't want all that there forever. Let me see. I want to show you something that's a little less. So tell me this. If I had 12 millimeters, is that a whole inch?
No.
No.
No. How much of an inch is it? Well, it's 12 out of 25.4, right? How much do I have on the way towards a full inch? I've got 12 out of the 25.4 that I need. So again, that's two reasons why this ends up dividing. So you could do all this kind of thing to figure out, do I multiply or divide? Or you could just set up the grid. And the grid, basically what the grid does is, I really, again, this is all on the side, but this is good shit. What the grid does is it either says, oh, you're in this situation, so the 25.4 is going to be on the top, or you're in this situation, so the 25.4 is going to be on the bottom. So the grid does all of this much nicer, much more efficiently. But that is kind of like the behind the scenes. This reasoning over here is the behind the scenes. All right, I think I missed a chat from somebody. Yeah, the hours, yeah, exactly. But I didn't want to talk about hours because everybody kind of knows hours. I want to talk about one that we don't know so well, the millimeters and the inches, yeah. Is that help somehow? Or is that do nothing for anybody? I do want you to believe in this. And I think part of what you're asking me is, I don't know if I can believe in this because it seems too simple, maybe.
Yeah, that kind of threw me for a loop, Jeff. Because when I look at it now and the way I did the homework, I'm gonna definitely have to do some corrections. But I see it clearly. I don't really, like you said, it's barely even math. So I could just look at the grid and let it do itself, and I just got to trust the process.
Most of the people that made mistakes in the homework did not do this for themselves. And they were just guessing about, do I divide or multiply these numbers?
Right.
That's what it does for us. It does all this freaky stuff more directly.
Mm-hmm.
It's like a machine.
Yes, that's technically it's an algorithm. It's an algorithm.
Yes. Yeah, but I do like the I guess the mechanics behind it, how you explained it right now. It gives it more of a deeper understanding for me.
Yeah, it's just the firmer footing. Even if you didn't understand what the shit I was talking about over here, this is sitting on firm footing, right? So maybe you'll buy into this more about why it works. Because I don't know, if you don't agree with me that this is easy, I'm not trying to say to blame you for that, but I want you to you got to let go and realize this is simple. I put the thing where it's going to kill the thing, and then I put the other unit there, and then I fill in the numbers. I mean, that's really just so nice. It kind of tells you where to put which number. And why does it work? Because there's only two options. So I should be able to make an algorithm that does one of the two options, multiply or divide. Okay, maybe.
It helps me when I make the grid, everything at the top I multiply, put it over there, and then everything at the bottom I multiply, and then I just divide them.
Oh, sure.
Together.
It's like balancing your checkbook, which nobody does anymore because everybody trusts the bank. But you could add up all your negatives and add up all your positives, and then subtract those two at the end, right? So what you're doing is you're multiplying all your positives, all the stuff on the bottom, and you're multiplying all your negatives, and then you're dividing those two, right? That's fine. Nothing wrong with that. All right. So so this is the most important thing I need for number 8, which is finally what the poor person asked about. They've been waiting patiently. So I'm going to clear all this away so I can move number 8 up here. All right. Did we ever get an answer over here, by the way? No, I didn't, but it's something, I think your calculator says blah, 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 E -6, right? Blah, 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 blah. No?
5.25.
5.25,
25.
maybe? I don't know. So it's going to be something really silly small. And we would never, I mean, if I just said to you, this glacier moving in miles per hour, you're like, what the hell? Why would you not use miles per hour? Because it's going so freaking slow. Why would I use it? It's sort of like, would I use centimeters to talk about how far the moon is away from the Earth? Would that make sense? No. So that's really what they're asking for. Number 7, why the shit would you use miles per hour when this thing is going so damn slow? All right. So I could use either like miles per year maybe would work, right? Or like they do here, inches per hour. That works because it's moving so damn, it moves 1/3 of an inch every hour. Yeah. All right. Which is basically what it used to be in traffic sometimes in San Diego. 1/3 of an inch is like really good sometimes. All right. So I'm going to clear all this. All right. We move down to number 8. So now the important thing to bring down to number 8, like I pointed out before, number is a throwaway. It's just sort of saying, okay, you can convert this, but would you? No. So we got 0.333 inches per hour, and it wants to know how long will it take it to move 100 yards? There are several ways to do this. And I've already seen some nifty ways people have thought about how to do this. The most direct way to do this is one of 2 things. You could either change yards into what so that it matches our speed that we have.
I changed it to centimeters.
Did you use this or did you use the 203 millimeters per? I can't remember what it was.
Yeah, I kind of went haywire with it. So I started off by doing the 2.54 centimeters in 1 inch, and then I went up to a foot. So I multiplied that by 12 to get.
Oh, okay.
I just kept going up and up from there.
One way is to make this go to so many inches, right? Because then that would match with this. Another way is to make this go to so many yards per hour, because then that would match with this. It's almost always better to go from the bigger unit to the smaller unit, because that's going to involve multiplication. You're not going to get, if you go this way, you're going to get smaller and smaller numbers. It's going to get kind of freaky.
Yeah, that's what I did.
So I can go from yards to inches, because now we know that direct thing. And then I go from inches, I can go from inches to hours, because I know this. Right, so I've got 100 yards. How do I make that into inches? Where would I put yards?
Bottom.
And what was that we figured out? 1 yard is?
36 inches.
And then I can go from inches to hours, which is not something I can always do, right? But I've got this conversion. I've got 0.33 inches per hour. So where's inches going to go?
Bottom.
Bottom, so that they cancel. And then I fill it in, 0.333 inches for 1 hour. And then I just do that. And it's going to be 10,800, looks like, roughly. So remember, one big thing I want you guys to realize is anytime you have a ratio like this, I get $10 an hour, or I'm moving 70 miles an hour, or something, that's an automatic conversion that I can use. You guys okay out there? Especially the person that asked me about number 8. Oh, I got a chat, sorry. Oh,
Yeah,
good, okay. No,
All right.
sorry?
It helped a lot. Thank you. I just
Sure,
did
sure,
it
sure.
backwards.
Yeah, and again, there are many other ways to do this problem. This is not the only way. It is the quickest, but it's not the only way. Some people were starting with 203 millimeters, but why doesn't that make sense? Because we've already converted it to be in our system of measurement. So I'm going to start with this, not with that. That's in the wrong system of measurement. Yeah. Oh, okay. Any other questions that you hope I will just do the whole problem for you? And I'm not going to, so too bad, but you can still ask. All right, I have to, I'm really sorry, but I have to do this. Hey, Wendy? 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 Does she have me muted? Wendy? All right, well, this is not good. I'm going to stop sharing for a minute. You guys just hang out. Let's see. There we go. All right. So, all right. So, quick word. I know I can't force everybody to turn their camera on. What's funny to me is if you have your camera on, you have to remember this is just like being in class. So if somebody whipped their phone out in the middle of class, I'm going to call that shit out. Now, if you have to get a phone call that's important, turn your video off, go somewhere. If it's an important call, right? That's fine. This is just normal class. Well, you know, as normal as it can be, but instead of a classroom, we got Zoom. Anyway, any other questions from homework stuff? All right, so we're gonna get back into where we left off. Let me see. Yeah, here we go. I think yeah, did we finish? Did we do this problem? Let me see. So we sort of looked at this problem, and this might help a little bit on a future homework problem. Did we do some of this problem? I can't remember now. I know I talked about this problem. Like how many students got a C on the final? Yeah, we did talk about this pretty well, right? Do you guys remember this? So how would I figure out how many students got a C on the final?
7%.
7% of what?
31.
31. All right, so in the calculator, you're gonna put what?
0.7.
No, careful.
0.07.
0.7 times 31, because that's what of means, right? And then you can round that because we're talking about, you know, people. You don't want to have 0.12 of a people. I don't want that. That's weird. What is that? Okay. So if I just drew this and I had something like this, well, that's really horrible, but oh well. Roughly what percentage is that of the circle? Let me see if I can draw it better. You could do it, Jeff. All right, maybe something like that. Poor little, somebody sat on my circle. What percentage?
Quarter.
It's about a quarter. Yeah, it's about 25%. Is about a quarter. Okay, so so if I drew something like this, that looks to be about half a quarter, right? A quarter is 25. Half of that is about 12. If you're just estimating 12%. So I mean, estimation. You don't have to have the problem exactly right, but if you told me something like that this was 75%, we're going to have a problem. So, all right, so you have to have some way, if they didn't put these percentages here, could you estimate what they were? That's one thing. So it's going to be a problem in this homework section or the next section. Okay. So coming back to this next section. Oh yeah. So this one's all about making guesses, inequalities. This is the one we pretty much finished, but I'm just now starting to get some homework turned in. So this is the problem I'm thinking about in the homework when we just did. It's a little bit freaky, and I will get to it someday. Here it comes. There. Okay. There are a few different ways to do this problem. The whole circle represents how much time. I'll let you look at that for a minute.
$11.
Good. So the whole circle represents 11 hours. And 11 is kind of a crap number. And this is all about estimation, right? So there's two ways to do this. You can either first estimate the percentage this represents and then estimate that percentage of 11. Or you could try to say, for example, let me change it to 12 because I'm just estimating. Let me make it about 12 hours, right? So how much would each side of this be then? How much would this side be and how much would this side be? They would both be 6 because it cuts it in half, right? So then something like this is going to be a little less than 6. Do you guys see that?
Mm-hmm.
So one way is to first estimate the percentage and then estimate that percentage of 11. The other way is to round that to a nice number that I can cut up in parts because now that's 3, right? Do you guys see what I'm saying? 12 is beautiful because I can cut it up in so many parts. And then you can figure out, well, that looks to be like a quarter, right? And so forth. Okay, that's all I'm going to say. So those are the two main ways to do that problem, to estimate, that I can think of. There might be another way that somebody creative can come up with. Maybe. I'm just looking ahead, trying to give you a little bit of a hint as to how to look at some of these problems. Okay. So you don't have to do it either of the ways I talked about. There might be other ways to do that problem. We did talk about the roster method. These are things you should actually already be doing in your life anyway. Kind of estimating how much a full set of something is going to cost, right? So it's kind of obvious how to round those numbers, right? Just be really careful when they say 2 pairs of jeans, they give you and then 3 workout shirts, $11.99 each. So don't just focus on the numbers. You got to realize how many of that thing you got. Okay. Blah, 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 blah. Oh yeah, and of course you want to estimate. This one's about estimating a tip, right? So I think I did a problem like that about how to estimate a tip, 20%, if there was good service. Okay. So that's enough of that section. Getting into this one. This is where things get kind of freakadelic. So this is the one about relative change, right? Also called percent change. And we've done a few problems from this. Let's look at some of this group work here. Oh yeah. No, that's kind of silly. So look at this first one. This is kind of silly. This is going to require some help from a calculator for sure. What's the relative change if I'm supposed to get 5 million and they only get $4,998,990? What's the relative change? So what are the steps? You could either memorize the formula, or you can just say, okay, percent change is change divided by either original or the amount they want to compare to, right? So here the original would be the amount of money I was supposed to get. So let me stop for a minute. So relative change really just means percent change. So if I want to know the percent of men in a room, wouldn't that be the number of men divided by the total? If I want to know the percentage of people that like Brussels sprouts, wouldn't that be the number of people that like Brussels sprouts divided by the total? So if I want to know the percent change, wouldn't that be the amount of change divided by some kind of total? Percent blank is blank divided by total. So how much did it, what's the difference? What's the change here? By the way, when I say change, I don't mean like you pay $5 and you get 22 cents change. I mean, how much did it change by?
0.99%.
No, you've gone too far. Just how much did it change by? By how much? Say again, sir.
$1,
$1.
like $9.
Not $1.
And
How much is
$10.
it?
$10,
$10.
yeah.
Yeah, right. That's $10 off, right? That's how much is off by. Yeah, there you go. There's Andrew.
Last one was a 9 and a 1.
Out of what it was supposed to be, out of 5 million. Now, if you put that in your calculator, right? And somebody pointed out this will be negative, but I can see it's going to be a decrease, but I can put that there. It's a decrease from what I was supposed to get, right? So if you put that in the old calculator, you're going to get something very tiny, obviously, divided by a huge number. What do you guys get? What does it say? Don't worry. Just tell me what it says. If you divide these, what do you get?
2 to the -6.
Yeah, so either it'll say 2e -6, or if you got a scientific calculator, it's going to say it some other way. So 2 times 10 to the -6. All right, here's a little review. Can you write that as a decimal?
Yeah.
Of that, good.
2 with how many zeros?
Shit.
0.50.
The other way. Yeah. Or 5.
5 zeros. Remember the shortcut? Always 1 less zero than the negative power is. I like it. So what is that as a percentage? Oh, calm down, Jeff. I know. What is that as a percentage? Everybody freaks out when the numbers grows. The number don't tell me.
-2%.
Huh?
No,
Negative 110.
Stop. How
Move it
many
twice.
times do I move? Yeah, move it twice. Once,
Negative
twice.
6.
So 0.0002%.
Oh, you moved it twice. Yeah, that's right, for the decimal.
The number never tells me what to do. I tell the number what to do. I'm the freaking human here, right? So I don't give a shit what the number is. How do I change from a decimal to a percent? I move the decimal over twice, to the right twice. No matter what the hell it is,
Right.
right? Don't let numbers tell you what to do. Say, you're a freaking number. I don't care. Once, twice, I'm done with you. So that is stupid small change. I might not even complain about that. I'm like, they dropped a $10 bill somewhere. I can let that sucker have that. I got the rest of this shit. I'm fine. But if you drop a $10 bill and you got $11, let's do that. They don't do that. They should have done that. So if I got $11 and somewhere along the way I dropped 10, so I go in the store and I got $1, what is the relative change from what it was? So how would I do that? What's the change divided by where it started? How much did my money change by?
10.
10, same as this, right? So I'm down 10. Out of how much did I have to start with?
11.
Yeah, so put that in your old calculator. What do you get?
110. 1 and 110.
Is it 90909? I don't know if I'm doing that right in my head.
Yes.
Yes.
Yeah. We'll stop there. So about 90.9% difference. So which person would desperately go looking for the $10 bill they dropped? More likely this person, right? Because it's a larger change for them that they lost that $10. So if I got $5 million and I'm talking about in bags and I'm walking along and a $10 bill slithers out, might I just keep walking and go, that's no big deal? I might. But if I'm this person, which is who I am most of the time, and I got $11 and a $10 bill drops out, I am gonna get that sucker, right? Because I have decreased what I had by almost 91%. Holy shit. Okay, maybe. This is why when the school says stuff like, we don't need to do anything about that because it only costs this much money to go to school. Well, it's like, you're comparing that to how much money you make. How about you compare that to how much money the students make? That's kind of a big, right? So, yeah. Let's see. All right. So everybody got that stuff? We're going to move on. So if you are somebody who prefers to memorize a formula, dadgummit, Albert, what are you doing? You can memorize this formula here. But to be really honest, this is the formula that I said I was using, and I don't even think of it as a formula. I just think of it as percent change would be change out of the original, right? But you can memorize this formula if you want to. That's fine, if it makes you feel better. I like to memorize ideas. It's just more efficient that way. Okay, so let's see. Let's try some more stuff out. Oh, well, number 3 doesn't really work for me. Have you ever had an instructor? So real quick question. Have you ever had an instructor that gave you a quiz that was like out of 10 or 20 points or something? Have you ever had like a 20-point quiz?
Yes.
No? Okay, I thought maybe for sure somebody did. Everything I do is out of 100 points, so this problem has nothing to do with me. But if you got a 14 out of 20 on a quiz, can somebody tell me what grade you actually made? This is a little side note.
70%.
So
Yeah, so this would be a 70%. So now watch. If I get 2 more points, if my instructor says I get 2 more points and I got 14 out of 20, what's it going to become from? So now that additional points makes it 16 out of 20. What is that?
80%.
80%. So my grade just jumped up by 10 percentage points, right? So if it was something out of 100, so I made a 43 out of 100, and my instructor says, I'll give you 2 more points. And you're like, wow, thanks. Right? It's sort of like saying, man, I'm $5 short. And somebody says, well, here's a dime. Wow, thanks. But if I'm like 9 cents short, somebody gives me a dime, I'm like, wow, thanks. Right? It's all about relative difference. How much does that relatively affect me? Okay. Maybe. Let's look at this problem a different way. Let me see. Can I erase something? No. Let me use a different color. So, let me see. No, I'm not going to do that on this problem. Screw that. I'll do that in here in a bit. So I'm going to clear this problem away. I don't want to put too much extra crap on this. Go away. Okay. Oh, shit. I like this book. It's so touchy. Oh, real quick. So this is not the way we would talk. If my budget, does this mean an increase or a decrease? Number 4.
Increase.
Because this is positive. But how would a real person say this? Wouldn't they say the word increase or went up? Wouldn't they do that?
Yeah.
Okay. And then look on the next page here. Nobody's going to say this, are they?
I will now.
Oh, man. We normally aren't going to say it changed by negative. We're going to say it went down by 3.5%, right? Isn't that what we would say? Yes? Okay. So these questions are kind of silly. You're never going to necessarily see that really. Sometimes you might, but okay. Blah, 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 whatever. Oh, okay. Oh, this is kind of an interesting one. I think this might be one we can work on. So look at this one here. So if you have your book, I'm on page I'm on page where are you? Page 231. Okay, so watch. Here we go. You guys are gonna do this. So there's $435 million spent to improve highways. If there's an automatic increase of 7% every year, how much is expected for that program in 2018? So take a minute, figure out what that is. I don't want estimation. This is not the estimation section. They want it to the nearest $1 million, right? Let me see if you guys can piece that together. So I got this last year, 435 million. There's an automatic increase of 7%. So where will I be now? I'm really curious if anybody remembers the shortcut for that. All right. Can somebody tell me what they are doing to do this? What are you doing to calculate this?
Multiplying 435 by 1.07.
There's the shortcut, kick ass. Remember that? An increase of 7% is to multiply that by 1.07. So it's one of these plus 0.07 of these. That's why that works. Or you could just do 0.07 times 435 and then add it. Is that cool? Right? That'll work too. It's basically what this does. So that comes out to be 465 point, who cares? Because they want me to round it to the nearest million. Let me put my little approximately.
465.5.
Yeah, but they want the nearest million.
Oh,
Right. So, yeah, that's this place. Yeah. All right. Now, suppose that 440 million is budgeted for that program. Did that increase or decrease from what was actually spent last year?
Increase.
It did increase. Did it increase as much as it was supposed to?
no.
No, this was what was supposed to be done in 2018, right? If it was going to follow this 7% rule each year. Are you guys, let me stop for a minute. You guys with me? This is something that politicians love to do, and they do it one way or the other, depending on which way makes their case better.
So they're about 25 million short.
Yeah,
So
from what
7%.
it was supposed to be. I like it. So now watch this. Find the actual change and relative change in the amount spent to this budgeted amount of 440 million. So how much changed from what was spent, right? It went up by 5 million, right? I mean, I'm sorry. Yeah, 5 million. Out of what would go on the bottom of that? So that's the change. The actual change is it's up by 5 million.
440 on the denominator.
Just to make sure you guys understand why I'm looking at the numbers, the amount spent in 2017 to this budgeted amount of 440. So there's the amount spent, and it went up to 5 for the amount budgeted for 2000. Okay. And what would go on the bottom, be careful. Well, what goes on the bottom? What's the formula say? It's new minus.
435.
Yeah, it's always on the bottom is going to be where you started. And then, whatever the hell that is. I don't know. One. I think it's going to be like 1.2. I don't know.
I got 0.0114.
Blah, 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 blah. Yeah, so I get, do they tell you what to round it to? No. So we're just going to round it. So the next number would have been 9. So if I go once, twice, that's 1.1%. If I round it to this place. So it actually, the amount spent increased by 1.1%. Which is way less than what it was supposed to increase by, but it still did increase. You guys with me? Roughly? Okay. I'm going to clear all this stuff. I got to figure out a better way to do this, but all this is going to go away. A news article reports that this program has been cut by 5.4%. So if you just saw somebody say the amount of money we spent on the highways was cut by 5.4%, does that match what we just saw? You can see where they got
Very
that.
close.
No. All right, let me try.
What is it? What?
The amount that we spent on highways. Did the amount that we spent on highways increase or decrease from 2000?
It increased. Oh yeah, it
increased.
increased. Yeah.
It increased. So, but do you understand why they say it was cut by some amount?
Because of it didn't meet the 7% increase.
Exactly. But is that honest?
No, because it make it seem like they didn't get any increase.
Yeah, it looks like it's kind of like they're saying we're spending less money now than we were last year, which is wrong. We're spending 5 million more. It's just we're spending less than we should have increased by, right? So this kind of thing, this is a very simple example of the way that people can just spin these things around to make the public feel like certain things are happening when that's not true.
Mm.
And it's really hard to check if you can't get a hold of the actual data. If you just have somebody spouting percentages at you, you just go, well, what? Shit, damn, those people, rah. And then, no, they're just technically right, but they're saying it that makes you feel a certain way. Anyway, so the more math you know, the more decisions you can make for yourself instead of relying on some other idiot to make sense of it for you the way that they want it to come out. I'm not trying to push my ideology on you. I am always trying to get you to a point where you can actually analyze things for yourself and not have to rely on anybody, me included, to tell you what to think. All right. So that's an example of using what they're teaching us to show you why it's important to know how to do it. Right? You might be able, if you get a hold of some real data, you could analyze it yourself and see what the hell they did. All right. And then this last guy is sort of the same idea. It's the percent error. So it's kind of like, so for example, if I saw a party off in the distance and somebody said, hey, how many people do you think's at the party? I'm like, I think there's about 30 people. So 30 people's my guess. And then we get to the party and then we count the people and there's actually 22 people. What was my percent error? Well, how do I find percent blank, percent anything? Is I find that thing and then I divide by some total or some, so here you can see it's going to be divided by the actual amount. So how much was I off by purely? How much was I off by?
8 people.
I was off by 8 people. And I'm going to divide by the actual number of people.
Which is 22.
Yes. And then I could figure out what my percent error was. How far off was I? Yeah. And then I want to show you a similar example. Let me see. So whatever the hell this is, I think it's going to be 363636.
Yeah.
Yeah.
Forever. So 36.4% roughly. So this is going to be kind of related to the dude that just won the $5 million versus me walking around with 11 bucks in my pocket. So what if I looked off in the distance and I saw a party and I said, I think there's 3,000 people there. And we get to the party and we're really bored. They got no good drinks. They got nothing going on. So we just count all the people and there's 2,992 people. So how far off was I? So this is my guess. And this is how many are really there. So how far off was I?
8 again.
8 people
8
again.
So I'm off by the same amount out of the, what's going to go on the bottom?
299 too.
Yeah. So what the hell is that? I don't know. I'm not even going to try to estimate. You sure, Jeff? Oh, let's see.
0.27.
Seems like way too much.
0.27, something like that.
0.0026.
There we go.
Yeah.
So I don't know if you're making, so then it would be 0.27%. Yeah. So obviously, in both situations, I'm off by 8 people. Which situation, what was much more impressive is this one. Right? Say there's about 3,000, there's actually 29. It's like, damn, that was really good. If I'm over here, say there's about 30, 20, all right, whatever. And it has to do with this percent error relative to how many there actually were. How bad was my guess? That's really what that gives me. And it's exactly the same idea as percent change. In this case, nothing's changing. It's an actual and a guess, and how different are they? But do you see how it's the same freaking formula, really? It's really the same formula. Okay, maybe. So let's take a sneak peek at the homework, and then we'll call it a day. Let me see. Oh, there's more stuff going on here, by the way. Good, this is perfect. I was talking to somebody about a problem in the prep skills for this section, and there's one about calculating the area of a building. And I said, you would do this if you wanted to buy carpet. So here's a problem all about buying carpet, and you want to estimate how much carpet you need. So I'll tell you this. One of the most exciting things for me as a teacher, I think it was my 2nd year teaching. This dude came up to me after class and he said, hey, Mr. Waller, I redo interiors of cars. So he like puts material on the inside of a car. And he said, after your lecture last week, I figured out how to estimate the square footage of the interior of this car. And it ended up wasting a lot less of the material I use. And I was like, holy shit, can you be a guest speaker in a future class? Anyway, so that was really nice. So this kind of thing, the better you can estimate this, the better it's going to be. So this isn't really about estimation. This is more about getting the actual values. But they really step you through it in this problem here. Let me see. Okay, let me get to the homework so I can show you. Blah, 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 blah. Here we go. So here we go. The first thing is going to be interesting. What's wrong? A real quick thing to point out about the first set of problems. They want to know how many cubic feet of concrete to pour to support this hot tub. So it needs this foundation. 14 foot by 16 foot by 4 inches. If I want to find how many cubic feet that is, what do I have to do first? What's wrong about what they've given me?
You need the length, width, and the height.
That's right. I do have the length. I got the length, the width, and the height.
Convert
I
into
got
inches.
all. Yeah. Currently that's inches and I want cubic feet. That's feet. Shit. So
Yeah.
I'm going to have to convert that to feet. All right. And do you see how the book is definitely stacking earlier things we've learned? They're going to keep doing that, which is awesome, which is what math is. Now, here's the one I want to talk about a little bit, and then we'll call it a day. There was a problem earlier. I can't remember exactly where it was. And they were converting. So watch this. So 1 inch. This has nothing to do with this directly, but it's the math you're going to need for this problem. 1 inch is 2.54 centimeters. We know that. That's amazing. Wow. So if I had a little cubic inch, this is 1 inch by 1 inch by 1 inch. So that is 1 cubic inch. How do I convert that into cubic centimeters?
The awesome chart.
Yeah.
And the chart's going to save your ass. So one way to realize this, what is 1 cubic inch? Isn't that inch times inch times inch? Inch by inch. So for each inch, say that. For each inch, if I do 1 inch is 2.54 centimeters, have I killed all of my units I don't want anymore? That inch kills that
two more.
inch. Oh, shit. All right, let me do another inch. Oh, shit. Let me do another inch. There we go. Now I'm there. One thing I want you guys to realize, do you see how that works? So if I have units to a certain power, I can just write them that many times and make sure I write enough of these so that they all cancel. And doesn't it make sense that if I have cubic inches, I need to go to cubic centimeters, which is what I'm going to end up with here, right? Centimeter times centimeter times centimeter. What's another way to write 2.54 times 2.54 times 2.54? It's 2.54 to the
third.
Ah, that's interesting, huh? Or is it just me? Might just be me. So that is going to come in handy for this problem. Okay. That's enough to kind of get you started in that. I'm not sure if anybody's close to getting in there anyway, but keep track of those notes so you got them for when you actually get in that homework. Let's go ahead and officially call that a day. Let me know if you want to stick around and ask questions. Otherwise, you can head out. I'm going to be in my office hours today.
All right.
2 to 3. Everybody all right? Anybody have a question? I'm going to get out of here. See you guys.